So if you say 5x equals to 17, you ask to solve this. So you see, the 5x 17. So you put on log base 5, you get 17. You put down the calculator. Then you're going to get what x is.
Couldn't you just do x equals 17 over 5?
No, you can't do that. It's to the power. It's not 5x. It's okay. It's to actually.
Yeah.
You can do that one, or I can show you 2 ways to do it. Anyway, so if you put that one, or you can do this one. If you get that one, or you can take the logarithm of both sides. So when you take the log of both sides, I will teach you that one when we go to the law of logarithm. But if you put this on the calculator, you should get to what, like 1.76.
I don't have a calculator.
Okay. Let's do. Okay, if you have now because you have a calculator that can do things like this, I think the one you will get online or on your phone, maybe probably a scientific one that can make a lot of sense. Let's use that method. So, for example, now if you have if they say ax equals to b, to solve this question, they can ask you to take the logarithm of both sides. So when you take the log of both sides, and in logarithm, please pay attention. In logarithm, when you see to the power, you don't bring it back like this. So this one would be x log a equals to log b. Then x will now be equal to what? Log b over log a. Can you copy that one down, please? That's how to actually do it. Yeah.
Yeah, I've got it down.
So if you have something like this, then if you have 5x equals to 17, then you take the logarithm for the side. So you go with x log 5 equals to log 17. So x will now be equal to what? Log 17 divided by log 5. So I think you need to use this on the calculator. This one should be, yeah.
And then if I need to find x, I can just put that in the calculator if I don't.
Yeah. Just put log 70 divided by log 5. Then the answer.
1.758.
Yeah, 1.76, 1.76. Yeah, that's it. So I'm going to give you one to try before we actually move on to other things. So let me just give you one to try. Can you try this one? 5 to the x equals to 8. Can you solve it? I'm going to pause the recording. Yeah. So you got the answer correct. So no, let's actually move on to the rules of logarithm. So the power, so the power of x, you put that one to let's look at this, the rules of this thing. So evaluate this thing. So this the thing. So you put someone on the. So how to use calculator, which I think that you don't actually have one for now. So you don't really have one for now. That's the reason why we cannot actually go to the calculator in actually in details. Because of if you can get one, that was really going to actually make a lot of sense for us. So we're not really required to draw a graph. That's why I'm going to go over that graph with you. Yes. So you see exponential. So let's move on to so the differentials. No, yeah. So let's just move on to this one. That's So we also go to modeling because they want us to look at some engineering problems. That's actually what's related to logs. So look at that. Now, laws of logarithm, you can see clearly that there are a few things. I told you about it. So this one, you already have that one already. So when you look at these two, this is the product rule of logarithm. So if you have, what in indices, they ask you that if you say x squared times x cubed, it's going to give you x to the power of 5. You know that? It is, yes. So in logarithm too, it's similar. So if you have log a x y, because x and y, there's multiplication between them, so you can show what we write it to be log a x plus log a y. And you see, you can change that multiplication between x and y to actually what? To addition. So the same thing applicable to division too. Division will turn to what? To take away. So look at something like this. Log x over y will be equal to log x minus log y. Why? This one, I told you about, you can put this one down, I told you about the other ones together. So these are the major rules for logarithm. These are the major rules for logarithm. You can put that one down for reference purposes. Yes. So if you are done putting that one down, you can show it. Let me know so that we can do.
Yeah, I've got it down. Okay,
good. So let's now look at how can we actually apply this to solving problems. How can we actually apply it to solve problems? So you want us to be able to look at how to solve problem with logarithm. Let's solve the equation this equals to this. You want to find out what x is. So in this case, you realize that log x plus this, you know that, and this one. So to make it easier for you, you know clearly that you can turn this one to, okay, let's start from the easy part so that you won't just jump into this one that is just slightly complicated. So if you have something like like this, you have okay, let me just give you this one. I have I want to get to the ones that it's gonna be a lot more easier for you to actually comprehend compared to the ones that. So if you have two, so if you have something like this, I said we gave you 2 log base 3 x minus 5 equals to log 3 x minus 5 squared. So if you have that, so they ask you to actually work out what x will be. I told you about this law that if you have what's it called, a cube, you can turn it to 3 log a. It's like bringing the power down. So that means that the ones that you have the number behind them, you can actually turn it to power back. So you can turn it to, this one could give you log 3 x minus 5 squared. Can you see? I'll turn it back to this. Equals, yes, so that it can be the same power. Equals So I've turned that one equals. So I've turned it already. So that's what you can actually what test it there. So equals to that. So then this is the major question. So let me just start. This is the major question. So it's just about changing, applying those rules regularly. So this is the question. So I can write the question out. The question is 2 log 3 x minus 5 minus log 3 2x minus 13 equals to 1. That is it. So you turn this one to log 3 x minus 3 all squared. So minus log 3 2x minus 13 equals to 1. So from there, things are actually what now taking shape. So now I told you that when you see negative, what does it mean in logs?
No, I'm not sure.
Yeah, when you know, I told you when you see powers, when you see multiplication, it's going to be addition, you know. But when you see division, it's going to be what? No,
Subtraction.
Subtraction. So when you see subtraction, you can turn it back to division. So to make it slightly what easier for you, turn it back to what? To division. So from there, it gives you log 3. So that gives you x minus 5 squared over 2x minus 13. Yeah.
And then wouldn't you put brackets around the fraction and then equals 1?
Yeah, everything is equal to 1 because you are taking the log of don't forget that you're taking the log for everything. It's going to be equals to 1. So it's like for you to know that equals to 1, log 3 equals to 1. Know that? So just put that one there. That's going to be equal to let's put it equals to 1 now. Okay, let's put that one to be actually what to be equals to 1 directly. So because if you want to remove the log from this side, just take so you move it here. So that gives you x minus 5. So can you expand that? Okay, there's no even point expanding that for me. So you can just put that this one is what? X minus 5 all squared 2x minus 13 equals 3. Because if you take the log from both sides, see this one is going to be actually what? Going to be 3. So then you now cross multiply. You multiply this by this. That gives you x minus 5 all squared equals to 2x minus 13. Then, so what can you expand this one for me, please? X minus 5. Can you expand it for me, please?
X squared minus 10x.
Yes, x squared 10x
plus 25.
Yes, equals to, can you expand this one, please?
6x minus 39.
6x minus 39, yes. So you now collect the like terms together, So let's collect like terms together. So that gives you take away 6x from both sides. So that gives you x squared minus 16x, Then you add the 39 to both sides. That gives you 64 plus 64 equals to 0. That's the answer. Yeah, you can just put that one down. Write that one down. Let me pause it. So I would like you to look at that example and try one similar to this exactly. Follow it step by step. Just copy that first before. So like I told you, this is the highlight first. You have to make sure that, I get this one back to what, or the power. Right? So that gives me log 5, 4 minus x equals to what? Log 5 x squared equals to 1. Can you see? Look at x squared equals to what? Equals to 1. So since you have seen that is actually what equals to 1, so it's now getting better. Sorry, you just put that one minus this, minus that one. Sorry, I will use for that. Minus that. equals to what? Equals to 1. So, and what do you have to actually what do after? So basically, you just need to do, because it's take away, divide. So it's go with 4 minus x over x squared. Then you put log 5 there, so that the bracket can cover it. So everything is going to be equal to what? Equals to 1. So everything is equals to 1. So I told you that this one will now be 4 minus x over x squared equals to 5. Know that? Because of log 5 is 1. Like the other one was 3. So then you now cross multiply. The same thing, 5x squared equals to 4 minus x. Then you now make it to be equal to 0. So that gives you 5x squared plus x minus 4 equals to 0. So you can put that one down. Then you now try one yourself. Solve it. This one.
Is it 8x squared minus 10x minus 3 equals 0?
8 what?
8x squared minus 10x minus 3 equals 0.
That's a very good job from you. That's a very, very good job from you.
I got really confused because do you know when it was like, because after I simplify, I got 11 minus 6x over x minus 1 squared equals 8.
Yeah.
And then when I took it out and I had to do it, I don't know, it's weird because I haven't really done anything like this. Like I knew how to do it. I just had to take my time with it.
Yeah. But that's very impressive for you to, you've not done things like this, and you were actually was able to, to figure it out. That is very, very good. I'm really, really happy about that, because a lot of people will give up easily, without just looking at it. Oh, I've not done it before. Trying to. So let's look at the application of it. How can we actually apply knowledge of how can we apply this knowledge to engineering? What can we actually do to apply knowledge to engineering? So that is our main target now. So let's look at so this is the final one. It's about this one. So you might have this one as your assignment. A research engineer is testing the effectiveness of a braking system on of a car when it's driven in wet conditions. So the engineer measures and records the braking distance, D meters, when the brakes were applied. The brake are applied at a speed of what? V kilometers per hour. The graph D against V and log this against D were plotted. They explain how figure 6 will lead to engineer to believe that the braking system should be modeled by the formula. This, based on what you can see, why do you think that it should be modeled that way in exponential? Based on what you can actually observe, why do you think that it's better to model it as what, like exponential that way?
Because it's constant upgoing pressure. It's not an exponential where it'll start off slow and then go up massively. It's constant. It goes up straight.
Yeah. So that's actually what's good. It's modulated state. So, but you have to be able to show explain use the information given in figure 5 with this thing, with K to be what? K is 0.017. So, what I would do basically is that I would like to reserve this question for you as an assignment to do. You try your best and actually do it and see exactly what you got, how you can actually come about it. It's very, this is just application of your knowledge to it. So are you on the group chat? Can you say hello there, please? I'm just maybe on the group chat.
On WhatsApp.
On your WhatsApp, yeah.
Yeah.
Can you just say hello, please? Just say hello to the WhatsApp and just say hello. Where is the assignment? I'm sending it to you.
Where's the assignment?
Just say hello and where is the assignment?